Okay, so I'd like to welcome Dr. Raymond Smith, and he's with the U.S. Environmental Protection Agency. He's going to be talking to us today about GREENSCOPE, comprehensive and systematic sustainability evaluation tool for chemical processes. So as different chemical processes are proposed, one of the desires is to be able to understand the impact on the environment, and so this new software tool is going to be an important part of being able to evaluate new technologies as they come online and as they're proposed. Let me just say a little bit about Ray. And Ray he's a chemical engineer. He's been with the U.S. EPA for over 15 years, and he has a PhD from the University of Massachusetts Amherst. He has a wide range of experience in biofuels, industrial ecology, process design, sustainability indicators, optimization, decision making. And combined with that, Ray has been very involved at the national level, with AICHE. He's also serving as the first chair for both the environmental division and then in 2016 the Sustainability Engineering Forum. And for those of you who are at the AICHE conference, Ray had a number of contributions there, and he's certainly establishing himself as somebody to look to lead some of the discussions about sustainability and how we go forward in the future.
I'm going to talk about GREENSCOPE mainly, and part of that will be the method, the tool, and part of it will be how someone could make decisions using GREENSCOPE. Part of my idea in talking to CAST community is that perhaps people will be interested in how they could use the indicators in GREENSCOPE in their analyses. You could have numerical methods and use these indicators in there. So to start, I'd like to say a little bit about EPA. So at the bottom left, I'm in the Chemical Safety for Sustainability Research Program. The EPA has many offices. Some of them are related to media like air, water, solid waste, toxicity. Others are regional. There are 10 regions. I'm in the Office of Research and Development. Within that office, there are a number of laboratories. I'm in the National Risk Management Research Laboratory. And then we have divisions within that lab. And I'm in what's called the Sustainable Technology Division. And the reason I bring that up is I want to talk about, to start off, I want to talk about some of the tools that we have in the division. And my screen is not currently responding. Let's try this again. Yes, thankful. Okay, so these are the sustainability tools that I wanted to highlight from our division. Paris, using for industrial solvents. The idea is that if you have properties of a solvent and you're thinking, well, how could I maybe replace that solvent? Paris will look at the properties of your solvent and match it up within tolerance and say, okay, so here's a list of other solvents that you could use that match your criteria. And the idea is that it also presents, well, say, different environmental impact categories. And it says, okay, so this one has lower toxicity. So if you make this replacement, you could lower the toxicity of your solvent. And it does mixtures as well. The waste reduction algorithm is it's a way of looking at processes. It does a balance on what's called potential environmental impacts. And in the end, it reports either the potential environmental impacts exiting the process or the change from what's going in to what's going out. TEST is the toxicity estimation software tool. While it says toxicity estimation, it actually estimates a lot of properties. So this is a tool that's available. TEST is available. And it uses QSARs, quantitative structure activity relationships, to estimate properties for different molecules. Life cycle assessment is just a cradle-to-grave analysis, looking at how do we get resources out of the ground, make it into a product, distribute it, use it, and what do we do at end of life, looking at all the environmental impacts through that life cycle. And you can use that to define or show where are there some hot spots in terms of the environment, or you could do it in comparison, compare two things with the same function. Finally, I'm going to talk about GREENSCOPE. It's for process evaluation design, and that's what the rest of this presentation will be about. So if we are looking at making a chemical process sustainable, we might have an existing process, we might be imagining something in design, doing some experiments on developing a process. Well, what do we know about sustainability? We like to think of it in terms of these four areas. You can see there: economics, environment, efficiency, energy. And I'd like to add that in these areas, we also have health indicators. So we think we have social under the environmental compartment. So we believe we're covering the three pillars of sustainability here: economy, environment, and social. So we'd like to think of it in terms of a control process. So we have here showing sustainability transmitters, the ST, and sustainability controllers. And the idea is that you can control the design, you can control the renewable or non-renewable resources that are entering your process, you can control the releases to the environment. But at the same time, we want to know, well, how well are we doing? Are there places where we can improve? Are we doing really well? So part of the issue there is what benchmarks to use. And are we close to achieving those benchmark targets? So we developed a sustainability framework, and that is to have two reference states: a best target that we're defining as 100% of sustainability, and a worst case that we're defining as 0. They're normalized on a realistic scale, and then we have this dimensionless scale percentage for evaluating. It could be an existing process again, or even a part of a process or something new. So down at the bottom of the screen, you can see how you calculate an indicator in GREENSCOPE. It's just the actual value minus the worst case value divided by the range. All right. So this tool, I keep saying we, and I mean that because there's a number of people working on this project, and I'm pointing out a couple of my fellow collaborators, Gerardo Ruiz-Mercado and Michael Gonzalez. Gerardo is a chemical engineer, Michael's a chemist, and I think it's good to have that collaboration across disciplines. So there's a long name for GREENSCOPE, which I usually don't repeat, so if you'd like to read it there. But the idea, I think, of in GREENSCOPE is I like to think of it as looking through a lens. And what this lens does is there could be a lot of data coming at you. You could have tons of data based on a process. What I think this does is I hope it puts it in context so that the data is more informative. And I think that's the main idea of GREENSCOPE. So let me talk about, again, in these four areas. As you can see, these little pictures across the top: environment, energy, efficiency, and economics. GREENSCOPE is a spreadsheet tool. It is newly a beta software tool capable of calculating about 140 different indicators in those four areas, those four E's at the top. So something I'd like to mention at this point is that we are looking at beta testing the software. So if this is something that strikes you that you'd be interested in beta testing, please contact me. Some options within GREENSCOPE is to choose which indicators to calculate, and you can redefine those best and worst case limits to fit the circumstances. And I'll talk a little bit more about that later. So, about using GREENSCOPE. let's start at the chemical process, where you have energy flows coming in and you have raw materials that you're using, creating products, and you have releases to the environment. So there's a lot of information then listed within that dashed box: energy flows, operating conditions, classification lists for hazardous chemicals, a lot of properties: physical, chemical, thermo, toxicological, and then there's data. To the left here, we have an arrow coming in on experimental data and literature and tools like tests that I mentioned earlier could be used to estimate some properties. You put this data into GREENSCOPE, you calculate the indicators and say, okay, well, am I satisfied with the results? If you're not, then this is at the point where you get to use your discipline, your engineering or science, and do some different design work or do some experimental work to change the process, to improve it, to optimize the process, right? You come up with a new process design and then run through the system again until you say you're satisfied with the results, and then you can say, well, okay, so this is a potential sustainable process. And there's a reference down at the screen, down at the bottom of the screen for that. So here's an example that has been published. You can see the reference at the bottom on biodiesel. So FAME, the fatty acid methyl esters, are produced from soybean oil and glycerol. Glycerol could be a co-product. Glycerol could be a waste, depending on the price that you could achieve. I'm fairly certain in this example we said it was a product. And there was a full simulation done on this, and I wanted to show that so that in the next diagram I'll be showing results, and I just wanted you to see that we went through this process of simulating the biodiesel process. So here we have 66 different environmental indicators calculated, and they're all on this one radial graph, where 0 in the center is the 0% sustainability, and at the rim, outer rim, is the 100% level. And so part of the idea here is for you to be easily able to in a summary way, see where you're doing well and where you're not. Okay, so if you're out near the edge, then the outer edge, then you're doing well in that indicator. Okay, and if it's closer to the center, then you're not. And I've listed some of those indicators along the right side there. And again, if something is really low, number 38, aquatic oxygen demand intensity, is almost 0. So that's somewhere where you probably need to do a lot of improvements. I'll show, for instance, the efficiency indicators. Again, you know, if you're at 100% or you're close to that, then you know you've met that limit, that best target. But if you're much lower, then there's an opportunity for improvement there. Here's the energy diagram. You can look at this. One of the things I like to point out is how easily you could look at this diagram and say, okay, well, number 1, 6, 7, 8, and 9 are all say below 80%. So I'm interested in looking at those 5 indicators for further analysis. And finally, the economic ones. Okay. So one of the important things to keep in mind when considering all of these is what those limits are, and we make them explicit so you know what 0 is and you know what 100% means by knowing what those best target and worst case values are. So I'm going to talk now about another example, which will lead into decision-making example. Here you see, I guess a cartoon is what people like to say for producing terephthalic acid. Just oxidizing p-xylene and then crystallizing the terephthalic acid out, and there's some separations that go about retrieving the acetic acid for recycle and other the methyl acetate. And this, one of the references for this is Schwartz et al., which you can see at the bottom there. So we're going to look at this in terms of decision making. So I thought what I would do is I would talk a bit about what some stakeholder interests might be. And, you know, these might not be your interests, but this is what someone came up with. That someone said, well, you know, I think energy is as important as CO2 emissions, CO2 equivalent emissions. And someone else said, well, CO2 half as important as water inputs. So that might be a sign that water is, you know, clean water or the water that's used in this process is valuable. Someone else, energy and material inputs are equally important. CO2 emissions, you know, someone did some math and figured out, oh, you know, looking at energy use and CO2 emissions, I want this ratio, you know, this ratio represented there. And then there could be more, right? This could keep going. So the list of stakeholder interests could keep going. So let's talk about these 4 sustainability indicators. They're ones that were related in those stakeholder interests that I presented in the last slide. So mass intensity is just the kilograms of input per kilogram of product, and energy intensity, kilojoules used per dollar of revenue, and similarly for global warming potential and for water intensity. Okay. And these are all presented in our reference there at the bottom on the taxonomy of indicators, sustainability indicators. So now that we have these indicators, how do we go about making decisions with them? So there are a number of ways. One is heuristics, and that is that, for instance, Jim Douglas, his book on conceptual design of chemical processes used a lot of heuristics in that method. An example being the optimal reflux ratio is 1.2 times the minimum reflux ratio, things like that, right? Another way is to create Pareto diagrams and have someone decide based on Pareto diagrams. So we did some work back in 2005 where we looked in multiple dimensions. So we went beyond 3 dimensions for Pareto diagrams. So I thought that was somewhat interesting. And you can, after seeing the Pareto, then you can choose points where you would like to trade things off. Another thing you could do is numerical optimization, and Ermila DeWicker's book is an example of something on numerical optimization. I expect this group knows a lot about that. So what I'm going to propose is to use an additive utility function. So it's just the total utility is the sum of the individual utilities, and they're weighted by these K values. The sum of the Ks is equal to 1, all right? So we can define each individual utility as at the bottom there, and that should look familiar because it's really the actual value minus the worst value divided by the range of values. So that's the way that we've defined the GREENSCOPE indicators.
So Ray, I just had a question about that. Earlier you showed the you know, the spider web plots, and you know, so those were indicating that you had maybe 15 or 20 different things for, you know, sustainability. So this is maybe adapting that a little bit by adjusting the slice of the pie or the size of the pie based on, you know, maybe water usage is very important, but percent that you use from recycled materials is less important. And so what you're doing is just adjusting the weights on those then?
In a way, yes. Thanks for the question. By choosing, so you can choose which indicators you want to include. In this case, to make it something that I can talk about, I've chosen 4 indicators. You could choose a lot more, okay? One of the things to point out is anytime you do not choose an indicator, that's essentially giving it a 0 value, okay? So that's the weight, rather. The weight on that indicator is 0. And yeah, so I hope I've addressed what you were trying to ask. So, but yes, yeah, let me get a little bit more into this, and I'll talk about how people might be trading off indicators. Okay. So I guess I ended up with the individual utility definition there at the bottom of the page. So I've written it up again at the top. And here's a table which shows for these 4 indicators what the worst case values are and the best targets are. So the best targets, that column is that they're aspirational, right? To only use as much mass as you're getting out in product, to not use energy, to not have global warming gases emitted, to not use water, right? The worst case values were taken from the literature. So those are all defined within that taxonomy paper, okay? How we obtained those values and determined them. One of the things I said earlier, I would talk about how you could change the limits depending on your circumstances. I like to point out the mass intensity one as one where that's possible and perhaps probable. That if you have a refinery, the amount of mass that your worst case could represent might be on the order of, I don't know, 1.05 or 1.1 kilograms going, input per kilogram coming out of product, something along those lines. Whereas if you have a different type of process, a pharmaceutical process, I've heard values along the order of 1,000 kilograms going in per kilogram coming out. So if you have a certain type of process, it would make sense to change these values, these best and worst case limits. And it has to make sense for your type of process. If you're comparing across processes, different processes, then I would recommend that you keep the worst and the best case constant for those comparisons. That way your percent values will mean something when you do those comparisons. So let's look at, using the data that Schwartz et al. Provided. We have this terephthalic acid base case. So they have the mass intensity and energy intensity, et cetera, in that first column of numbers. If you just had those values, you might be very familiar with the process. So you might know, that 1.13 mass kilograms going in per kilogram of product is a good or bad value. But what the GREENSCOPE column does is it puts things in context for you. So based on the limits that we are using, the mass intensity is very good, right? The water intensity is good. However, the energy intensity and the global warming potential are not very good. They could be improved. And that's something that Schwartz et al. Presented in their work. They presented an improved case where they improved the energy intensity and the global warming potential. And then you can see that reflected in the new GREENSCOPE scores for those 2 rows. So while there's still room for improvement, you can see how these things have gotten closer to these aspirational goals. So wanted to talk about trading off indicators. So I wanted to bring up the idea of marginal rate of substitution. Here we could have 2 things that we desire, both U1 and U2. And the solid line describes how you are willing to trade off one for the other. Between P and J, I've drawn a dashed line to represent a linear trade-off between those values. And so one of the things is that to consider is that when you have a lot of something, you're usually willing to trade more of it off for something that you don't have much of, and vice versa. When you don't have much of something, you want a lot of something else to trade off the little that you have. And that's why you see the different slope in this diagram. So I'll be using this linear marginal rate substitution area in this analysis. And at the top of here is an equation for that. between two categories. And here I'm assuming that the weight, the K values are weighted equally. And here's a table showing the trade-offs that exist based on the best and worst case values and the weighting values of being equal. So this says that, let's look at the energy intensity column. It says that it takes about 956 kilojoules per dollar revenue. You're willing to trade that off for a kilogram of mass input per kilogram of product, okay, and so forth down that column. And so what that, putting things into a category like that column on energy intensity lets you do comparisons or add the categories together, essentially. Okay, excuse me. So I'm going to do some combining of equations. This is the total utility equation I presented earlier. This is the equation for the individual utility. And then here's the marginal rate of substitution equation. And I'm going to combine those into a new total utility equation. So now we have this, the calculation of the total utility is just based on the marginal rates of substitution and the attributes, the X values, and you have to have the worst case values as well. We can also do some substitution, and this is essentially taking the GREENSCOPE equation that I presented earlier to calculate %G and rewriting it in a form where we can substitute, and we come up with the total utility in the form of just the % indicators, the GREENSCOPE indicators, the ranges of values, and the marginal rates of substitution. One thing I didn't mention this when I was showing that table of all the marginal rates of substitution. It was showed each column where you could say, oh, the energy ones. I weighted everything equally in that. And one of the things I'd like to point out is that a lot of people use that terminology. They say, well, we weighted everything equally, but they don't like to admit that, well, that you're actually then producing very distinct value judgments. What they'd like to do is to say that they're not making value judgments, but really, they still are, and that's part of what I'd like to present for that. Sorry, past that at first. All right, so back to this total utility equation using the GREENSCOPE indicators and the marginal rates of substitution. So how can we determine the weighting factors and the marginal rates of substitution? Based on those stakeholder interests that I presented before. So if you remember, I said energy is 1/3 as important as CO2 emissions. So I can say K3 equals 3 K2. And again here, K3 is half K4. K1 equals K2. And this, someone did some math and determined their ratio between CO2 and energy use. It's K3 equals 2.41 times K2. The other thing we have is that the sum of the K values is equal to 1. So we want to calculate the 4 KI values. However, we have 5 equations, right? So we have an overdetermined system. So when we here are those 5 equations at the top. In this case, we calculate the 4 KI values. What we used was we used the singular value decomposition to do that analysis. And you can see that each of these equations is approximated. So the sum of the KI is not exactly 1, but it's close. The ratios of K3 to K2 and K3 to K4 are approximating the equations. And K1 is close to K2. Then we can calculate the marginal rates of substitution because we have those K values. Now, what I'm going to do is look at another case where we knock out one of these equations, right? So we're going to have now we're going to have 4 equations, 4 unknowns. So now the things are matching exactly, right? K1 does equal K2, K3 is a half K4, K3 is 2.41 times K2. The sum of the Ki is equal to 1, right? And again, we can calculate the marginal rates of substitution for that case too. Finally, another case, we knock off another equation, and we say, okay, now we have 3 equations, 4 unknowns. So we solve for the results in terms of K2. So the K values can all be solved for in terms of K2, and as well as the marginal rates of substitution, where you can see that one is dependent on K2 as well. So the idea here is that when people, stakeholders give you their interests, there's not going to be a nice, often there's not going to be a nice, neat number of their desires. It could certainly not match up with the number of equations. You know, I mean, it produces the number of equations, but the number of indicators that you have, right? So that mismatch can lead to over-determined systems or under-determined systems. So I'm going to look at use the case 1 values for the marginal rates of substitution and continue this example. So those values are repeated here in that column MI2. And those are essentially the weightings, the marginal rates of substitution that you're willing to say for energy, okay, energy use. So this goes back to the TPA base case is the data that Schwartzel presented, and there you can see the total utility based on those values. And then you can see the total utility based on their improved case, right? And so what you would say is, okay, so by going to this improved case, we've increased the total utility, and so it's a good idea to move to that improved case. I want to give you a however case, and that's, okay, say we do this improved case, but now we're using 10 times as much water. So if you look at the column water intensity, or row water intensity, we've gone from 0.041 to 0.41 in terms of meters cubed of water per dollar of revenue. And now the total utility is around 275,000 instead of 306 for the initial base case. And so we've actually decreased the total utility. And so this would suggest that, no, we shouldn't do it in that case where we're using so much more water. And the reason why the utility goes down so much for this case is because you could see the high weighting in that marginal rate of substitution column. It's the 133,000 value there is weighting water use very high. And so the change when you start using a lot more water, it affects your total utility score. So I'm going to summarize now. So the GREENSCOPE indicator scores and the best and worst case limits are available for people who want to use them in computer-aided process engineering applications. I'm just emphasizing that stakeholders seldom provide a neat set of equations for defining their preferences, you know, their values. So I've presented the method for calculating the weighting factors and the marginal rates of substitution. And then having calculated those or selected the marginal rates of substitution, you can easily calculate a total utility, and that is a method people could use to make decisions. All right. So I have to end with a disclaimer that these are my views, not those of the EPA. And I thank you for listening and watching.
Great, thanks, Ray. Great presentation. So we're going to enter the discussion portion now. So if you'd like to unmute your microphone or also use the chat window. If you haven't done so already, if you could put your name, your affiliation, and then some of the things that you're interested in or working on in the chat window. We've had a couple of additional people that have arrived after we did the initial introductions. So go ahead and put that in the chat window. If you want to open that up, you're also welcome to post questions to the chat window if you'd like as well. Okay, so anyway, any questions from the group I'll just go ahead and open it up to questions now. And don't forget to unmute your microphone if you'd like to ask a question. Okay, so Ray, just so I just wanted to follow up on one other related question to one that I asked before. You talk about some of those K values and how you weight the importance. And sometimes it's hard for people to say, this is worth, this percentage. Is there any work that's been done to try to understand existing systems that are put out there and then try to fit K values? So you say, hey, here's a system, and then try to deduce or infer what those K values were from how they made decisions in the project.
That's interesting, John. I had not thought of that, but I think that I haven't heard of people doing that, but I think that could be done. What I would look at is I would start with the marginal rates substitution, because those are more intuitive for me than the K values. But you could look at and see, based on what people have done for processes or doing, and say, okay, they're willing to trade off, this much, say, CO2 emissions for, this sort of revenue or some other indicator of interest, and it would show what people are doing. From those marginal rates of substitution, you could calculate the K values, the weighting values that you're interested in. So yeah, that would be interesting. Go ahead.
I guess one of the reasons why I asked that is because when I was working in industry in a chemical plant, I designed an optimization program that would have saved the company, a lot of money and reduced some off-spec product that we would potentially make. And I worked for a month or two on this program, was ready to implement it, and then went to the stakeholder and presented this to him. And he had one question. He said, well, how is that going to reflect on my metrics? He was always tracking these metrics. And I said, well, it's going to make you more profitable, the company more profitable, but it's going to actually cause your metric to decrease. And he said, well, we're not going to implement it. And I said, that's amazing. You're just driving to metrics and not to, so there's a process to, override the metrics and say, hey, this really makes a lot of sense. But, it kind of surprised me that, he was really driving toward his metrics that reflected on his ability to run the process and manage that unit. So anyway, I just thought, as you presented, sometimes these metrics and what we drive towards can be even stronger than profitability for companies that are, if they're really judged by those metrics.
Right. Yeah, it's interesting what people value. Right. That's what you're pointing to, is what someone's values are. And that's one of the reasons I point out that table where I just said everything's equal, is because people like to say, oh, everything's equal, but they probably have some strong interests, and it might not be your interests, right? So I think that's an interesting case where the indicators that they were focusing on were very different than the ones that you would focus on.
Mm-hmm. So we have a couple other people online that have introduced themselves, and so I just wanted to ask a couple questions, maybe of some of those who have recently joined. We have Tom Adams. He's presented in the past, on his fuel cell design with carbon capture. And then we have, for example, Giancarlo. He's working on sustainable biobutanol production. So everybody has, these different applications you mentioned there's a spreadsheet that's available that, that people can, contact you and then you'll send them the spreadsheet, or is it available for download? What's the process of getting that?
Yeah, we would like people to contact us if they're interested in using the tool. That'd be great.
Okay, great.
My email address is there at the bottom, smith.raymond@epa.gov.
Fantastic. Okay, so any questions from those in the audience, with your particular processes, how you dealt with the many on the call with this, the CAS division working on optimization? How do you form your objective functions, and how have you tackled this in the past? So, Victor, do you want to say just a little bit about that? I know you've worked on this a little bit.
Yeah, so basically, hi, this is Victor from Argonne National Laboratory. We have been doing a little bit of work on multi-stakeholder optimization. I actually contacted Gerardo some few days ago about this. So the idea is that we want to collect the opinions of all these people and try to find some way of finding the best compromise of them in some way. And the problem is that it becomes a very ambiguous metric. But the idea, one way of doing it is essentially try to minimize the dissatisfaction of the stakeholders by pulling all this data information. So I have a question related to this, because in your decision processes, how many stakeholders do you normally have involved in the process? Are they 10, 20, 5? So I'm wondering how much data flows into this decision process.
So you're asking how many stakeholders? So this is Ray. I haven't been working with actual stakeholders making these decisions. The idea in presenting that was just to show an example where disparate ideas are coming in and you have to deal with them in some way. So if you could get a community, whoever is the decision maker, to decide on a set of values and therefore present you with either weighting factors or marginal rates of substitution, you could, use that method. Yeah. Okay,
great.
Thank you.
And Victor, that's kind of an interesting approach to minimize the dissatisfaction versus, maximize the satisfaction.
That's right.
What in terms of posing it that way, what's the advantage of minimizing the dissatisfaction?
Look, at the end of the day, what makes this, I think, in my opinion, I think that what makes this topic very challenging is, as you said, you get into situations where it's a chicken or egg problem, because you need to convince all these stakeholders that you're solving the right objective function. So if for them, let's say, I could say, you know what, I am going to satisfy 90% of you, and if they're willing to go with that, great. If you are willing to say, let's go for the average, right? So, like I'm going to please 50% of you, and the other ones might not be that pleased. If they're happy with that, that's great. So I think it's just a different way of posing the decision process to the stakeholders. And if they're willing to buy into that, that is great. But they should be aware that, that not 100% of them are going to be satisfied. So in some way, by thinking into minimizing essentially what you can think about is to say, look, this is the best I can do based on your preferences. And this is the best I can do for him based on his preferences. Now, I cannot implement this solution and please all of you at the same time. So what I'm going to do is try to find a solution that minimizes the dissatisfaction relative to the best solution that I could find for all of you. So in some ways, some sort of compromise solution relative to the utopia point, where the utopian essentially means the point that everyone will be pleased that we cannot just get. So I would say that it is an alternative. I'm not sure that is the best one, but it's, if you can convince the stakeholders about it, then maybe it's an alternative.
Great. Okay. Well, thanks, Victor, for that insight. Okay, we have time for maybe one more question if somebody else would like to ask. And don't forget that your microphones are mostly on mute, so hit the red button. to unmute, or you can send a question in the chat window.
I guess I have a question.
Sure, Alex, go ahead.
How does GREENSCOPE deal with more generic parameters from the stakeholders? For example, in the presentation, a lot of the stakeholder parameters were very specific. Carbon emissions was to be 1/3 of production. But how does GREENSCOPE deal with parameters that are more generic, like just a maximizing of profitability or minimizing of pollutants, et cetera?
Okay. Well, thanks for the question. So I guess I wasn't clear in one aspect, is that the decision-making part of what I presented today has not been fully implemented into the tool. So what I was suggesting was that was one method that people could use the indicators that GREENSCOPE produces to, make a decision, but other methods would be fine as well. I think it's depending on the limits that people place, those best target and worst case, they will emphasize or de-emphasize each indicator. Okay, that's something you have to be aware of, right? If depending on where you place those limits, you could put different emphasis on the indicator, and the idea of heading towards say zero emissions, just decreasing the emissions as much as you can. That's that's within the realm of what could be done. I think you have to look at the other indicators and say, okay, well, how much am I willing to trade off these other indicators to reduce those emissions? And the same thing with, say you wanted to increase profitability. Well, how much what am I willing to give up to in terms of that profitability to do other things with the process? I'm sorry if this isn't a perfect answer, but that's a difficult question to deal with.
Okay, fantastic. We also have Jose Pires on the line. He's in Portugal, a postdoctoral researcher working in sustainability assessment. Jose, I just had actually one question for you. Being in Europe, how is this trade-off or sustainability discussion going in Europe, and what are some of the differences that you've seen with the U.S.? Do you want to say anything about that? So, Jose, I'm going to take you off mute. Can you hear me? Okay, maybe his microphone is not working. Okay, well, we'll go ahead and pass on that one. But Ray, do you have any comments on that? I know you've probably worked mostly in the U.S. What have you seen with how this, because one country can say, here's, sustainability efforts, but how does that, unless others buy into that as well, it's sometimes hard for companies to make changes if they feel like they're at an international, competitive loss.
Mm-hmm. Mm-hmm. So I guess the first thing I want to say is I don't want to talk about policy, EPA policy. What I see, people are doing the best they can. A lot of companies are public, and they have they need to increase shareholder value. So that's going to be their emphasis, and perhaps they look at the regulations as constraints on that. That's one way of looking at it. We're emphasizing the idea that people want to do the right thing, and so we're giving them tools. We think especially early in the design process, when you're thinking about some new process, if you were to apply this tool and use it, I think, interactively. So I'm thinking someone's doing experiments, they go to GREENSCOPE, put in their data, they get some results, they see what the results are. They, again, could maybe modify what they're doing in their development of the product, the process, and keep doing this iterative process to improve things. And that could improve a lot of different indicators. So the idea is to help people do the right thing.
Great. Okay, well, Ray, thanks again for the presentation and the answers that you gave. I thought the presentation was very interesting and informative. And it's great to see how we can start to formulate maybe better objective functions as we work on optimization and design of renewable or other types of processes and having some metrics. So very, I think, rich information there. A lot of things to think about. So thank you for delivering that presentation.
Thank you, John. Thank you, everyone.